Hello friends, welcome to this video. Today, we're going to explore one of the most important topics in Java programming, object-oriented programming, or OOP. Now, this is not just theory. These concepts are used in real-world software like banking systems, mobile apps, games, and enterprise applications. So as we go through each concept, try to focus not just on what it is, but also why it is used. Let's begin with the fundamental idea of OOP. On your screen, you can see two approaches. On the left is procedural programming, where data and functions are separate. This approach works fine for small programs, but as the program grows, it becomes difficult to manage. On the right is object-oriented programming. Here, we combine data and behavior into a single unit called an object. Think of it like this. Instead of having loose variables and functions scattered everywhere, we organize them into meaningful structures. For example, consider a mobile phone. It has data like battery level, contacts, and storage. It also has actions like calling, messaging, and charging. In OOP, all of these are grouped into one object. This makes the program more natural and closer to real-world modeling. Now let's understand why OOP is so powerful. On the screen, you see repeated blocks of code. This represents a common problem, code duplication. Without OOP, you might write the same logic again and again for similar objects. But with OOP, you define it once and reuse it. Example, you create a car class once. Now, you can use it to create 1, Honda 2, Toyota 3, Tesla. Each car shares common behavior, but can also have unique properties. This saves time, reduces errors, and makes your code easier to maintain. Now let's clearly understand the difference between a class and an object. On the screen, you see a blueprint transforming into real houses. A class is a blueprint. It defines what an object should have. An object is the actual instance created using that blueprint. Let's look at the example code. We define a class called car with a property color and a method drive. Then we create two objects, C1 and C2. Now observe carefully. Even though both are created from the same class, they can behave differently. We assign 1, C1, red doys, say doys blue. This shows that objects share structure but have independent data. This is a concept many beginners overlook. A class itself does not occupy memory when defined. It's just a template. Memory is only allocated when we create objects. On the screen, you can see memory blocks appearing when objects are created. Each object gets its own memory space, which is why changes in one object do not affect another. Now, look at this example on the screen. You see names like Parker and Reynolds. At first, they don't clearly mean anything, but once we define the class pen, everything becomes clear. So a class gives identity and meaning to objects. It defines 1. What properties an object has. 2. What actions it can perform. Now, let's move to encapsulation, one of the most important OOP principles. On the screen, you see a box with a lock. Encapsulation means 1. Combining data and methods into one unit. 2. Restricting direct access to data. Real-world example, ATM machine. You can withdraw money, but you don't see the internal process. Let's look at the code example. We have a bank class with a private variable called balance. Because it is private, 1. You cannot access it directly. 2. You must use methods like deposit or get balance. This protects the data from being misused. Now observe the visual. When someone tries to directly access the balance, it fails. But when they use a method, it works. This is very important in real-world applications like banking or security systems. Encapsulation ensures 1. Data, safety. 2. Controlled access. 3. Better maintainability. Next, we have inheritance. On the screen, you see a hierarchy. Animal gives dog. Inheritance allows a class to reuse the properties of another class. Think of it as a relationship. Dog is an animal. Instead of rewriting code, we reuse it. Now look at the dog object. It can 1. Use eat from animal. 2. Use bark from dog. This demonstrates code reuse in action. It also helps in building structured and hierarchical programs. Now, let's understand polymorphism. The word means many forms on the screen. One person plays multiple roles, teacher and parent, same person, different behaviors, depending on context. This is exactly what polymorphism does in programming. Now we look at method overloading. Same method name, different parameters. Why is this useful? Because it improves readability and flexibility. Instead of creating different method names, we reuse the same name. The compiler decides which method to call based on parameters. Now we move to method overriding. Here, the child class changes the behavior of the parent class method. This allows customization of inherited behavior. This is very important. Even though the reference type is animal, the actual object is dog. So the method of dog is executed. This is called runtime polymorphism. Now, let's understand abstraction. On the screen, you see a car. You only interact with 1. Steering 2. Pedals, but you don't see 1. Engine 2. Internal mechanisms. Abstraction hides complexity and shows only essential features. An abstract class is a class that cannot be It may contain methods without implementation. It acts as a base structure for other classes. An interface is like a contract. It tells a class, you must implement these methods. This ensures consistency across multiple classes. On the screen, you see a comparison. Key idea. 1. Abstract class equals partial abstraction. 2. Interface equals full abstraction. Interfaces also support multiple inheritance. Now look at this key word. It is used when there is confusion between local and instance variables. It helps refer to the current object's data. The super keyword is used to access parent class members. It is useful when 1. You want to call parent methods 2, or avoid duplication. Now, the final keyword, it is used to restrict modification. Think of it as locking something. 1. Final variable gives constant 2. Final method gives cannot override 3. Final class gives cannot inherit. This ensures stability in programs. Let's bring everything together. 1. Class. Blueprint. 2. Object real instance. 3. Encapsulation protects data. 4. Inheritance. Reuses code. 5. Polymorphism flexibility. 6. Abstraction hides complexity. These concepts are the foundation of modern Java development. You've just learned some of the most important concepts in programming. Don't just practice these examples yourself. That's where real learning happens. If you found this helpful, don't forget to like and subscribe so you won't miss the next one. It really helps to support the content, and let me know if you want more videos like this. Thanks for watching, and I'll see you in the next video.